So, hello guys, welcome to day 3 of problem solving for placement 2025. Okay, so the today's question is, so it is daily practice problem of lead code DPP. We can say DPP lead code 3. This is our day 3. Okay, so this is a question. I already solved the question. That's why I want to discuss with you. So here's the question. This is the question of graph. Let's summarize the question. Here's the question. There is given that in the question given that here is a node 0 to n minus 1 means total n nodes. This is given in the question, and every node is connected like this: 0, 1. Suppose I am assuming that there is 4 nodes, n is equals to 4. That's I am assuming at this time: 0, 1, 2, 3, and you have given a vector named query. Okay, there is you have given an extra edge. Suppose here, suppose given 2 to 4 and 2 to 3 or 1 to 2. Suppose here you given 1 to 3 or 2 to 3. Suppose you have given 2 extra edges, 1 to 3 and 2 to 3. Now what you have to return? You have you have to traverse in the query vector. You have to traverse in the query vector, and simply this is given a edge 1 to 3. So minimum number of steps that you require to reach this point, to reach the n minus 1 point, that you have to return. So what's the minimum number of steps you require from 0 to n minus 1? So this is one steps. Let's change the color. This is one steps, and this one is second step. So for this you have to return an vector in the answer. So for this 2, and for this 2 to 3, here 2 to 3. So what's the minimum number of, if you move from here to here, then require 2. If you move from 1 to 3, so you require 3 steps, but already you can reach to the n minus 1 in 2 steps, then you will return 2. So this is the question. So let's discuss about the solution. So let's move it. So how I proceed? So first of all, we can use BFS. So first of all, this is a graph question. So we can use the traversal, that's a BFS. How I can use BFS? Like here, suppose I want to take this example again. 1 2 0 1 2 3 4. Here 0 1 2 3, and you have given an extra is 1 2 1 3 and 2 3, 1 3 and 2 3. Suppose here an extra is 1 3. For queries array, for first element of query, I am talking about the first element of query, you have given an extra 1 2 3. Then you can use a BFS level order traversal by BFS. So first level, second level, and third level, we can can use the level order traversal, that's a BFS. For first, second, we can reach to the n minus 1 in 2 level. That's why I can use BFS traversal. Okay, so now let's discuss about the code. So the code is very simple. Like we will use BFS traversal while not equals to q dot empty. This is a simple BFS traversal, q empty, and while in size equals to q dot size, and while size minus minus, while size minus minus, here if node equals to n minus 1, then return the level. Else I'll move in the neighbor of that's a node. For auto neighbor of that's node, it is a node, I'll move in the neighbor node and push in the q dot push and visit it. That's a simple code. Let's discuss about the code. So this is our code. Simple, use the BFS. It's a simple BFS reversal. If now use the condition if node equals to n minus 1, then return the level. And this is our question. First of all, let's create the adjacent list for int i0 adj push, because I already discussed that this that is a given in the given question. We have given that the edges are connected like this. That's why I am pushing like this. Adj I dot push back I plus 1, and for I'll move in the queries array or vector, whatever it is. So adj x0 I'll push into the queue. No, I'll push in the adj list. Here you can see I push it here. Let's change the color. I push the queries here. Adj I dot push back, because 1 to 3 we assume that 1 to 3, if there is edge 1 to 3, we assume that here I push that into the adjacent list. So simply I'll traverse in the queries vector and push into the queue. Then I use the BFS for this for this element. Suppose here the element 2 4, then I use the BFS for this element, and whatever level we got from the BFS, then we put into the result vector, and at the last we return the result vector. So this is simple code I am displaying on the screen. You can copy it. So thank you very much.